Ladies and gentlemen, hello and welcome back once again to the Briefing Room. My name is Eric Cavanaugh and I will be your humble if excitable host for the show that is really designed to get right down to the nuts and bolts of all these technologies to help you out there in the real world understand what they do, how they work, when to use them, when not to use them, and so on and so forth. So, this is your host, of course. I will be fielding the Q&A and moderating the Q&A at the end of this webcast. The title for today's event really speaks to what we're talking about here, folks. Predictive Analytics, a new wealth of options. Of course, Predictive Analytics has been around for a good long while. And hold on one second.
Participant lines muted.
Sometimes this phone conferencing thing acts a little funny, so my apologies if there are any hiccups like that. But once again, Predictive Analytics has been around for a long time. This is not terribly new stuff, but there are very new ways of doing predictive analytics. So we're going to learn about this pull model versus the push model versus the hybrid model. Of course, we're going to have SAP, or it's actually Sybase, which is an SAP company these days. They're now really formalizing that acquisition, so the Sybase teams are moving right into the SAP world, and from what I hear, everything is going along just fine. Obviously, there was a huge acquisition, and the implications are significant, and they are vast. I was on the conference call the other day as the leaders of SAP were talking about themselves, and they openly pitched themselves as a database company. So let's think about what that means. Obviously, you've got issues like Oracle and Microsoft, and they, of course, have databases. IBM has a database. But what SAP did is they started in the application space with ERP, and they kind of reverse engineered, if you will. They went out and they bought a database, a couple of them, in fact, from Sybase. And, of course, they have HANA, which is their real-time in-memory database we've heard so much about. Very interesting dynamic. Things are changing in the field of information management, and a lot of stuff is happening. You can now do in-database analytics, so that's a different way of getting the job done. So the point is that there are lots of new options about how these things work. You don't have to do it the same way you've always done it. It's just a different playing field. So very quickly, the briefing room is designed, again, to let you get down to understand the fundamental core of these technologies, what's going on. So ask questions. Please don't be shy. Send your questions in, and we will queue them up for the Q&A portion at the end. So with that, I'm going to push, hold on one second, I'm going to go ahead and push these slides from Joydeep. If you just give me one quick second here. Okay, now Joydeep, I'm going to give you the keys to the car, and you should have them now. So Joydeep Das, go ahead. The floor is yours.
Thanks, Eric. This is Joydeep Das from Product Management at SAP Sybase. So what I'm going to talk about in line with what Eric outlined is the various options available for doing heavy-duty predictive analytics on database platforms, and in this case, around Sybase IQ, one of the leading columnar databases for analytics that we have in the industry today. So with that, let me highlight some of the key aspects of these different techniques that we are going to talk about. So before we get to the meat of the techniques, just wanted to point out that there is a lot of buzz in the industry about predictive analytics, big data, and terminology of that sort. But the point here is that they actually have real value, real business value in terms of bringing about operational efficiencies when data is used in the right way and outcomes can be predicted ahead of time. Obviously, it leads to revenue growth, which is a big part of all businesses to strive towards continuous revenue growth year after year. But more importantly, ability to open up new business models and strategies. I mean, who would have thought when Amazon just started off with online e-tailing that they could branch out into so many different categories beyond just books, but all through their ability to harness and harvest data and provide analytics around that. I think that's been an eye-opener across the internet industry as such. So overall, predictive analytics, when combined with harvesting of data, can actually provide the big benefits that businesses are looking for. And that's why there's a renaissance around information management and analysis of data on them. The next aspect about the buzz is that it's not just on traditional data, but also new types of data, new sources of data. For example, social media, and we're all familiar with that because it's almost part of our day-to-day lives in terms of social media, e-commerce, looking at maps, geospatial data, textual data of various types. But the goal here is to take the information in these non-traditional data types. They are not transactional, but they have meaning and value that can be analyzed and combined with transactional data to provide more insight. So this buzz in the industry is also not just about traditional analytics and predictions, but also on new types of data. And the other aspect of it is that it's proliferating. It's not just the PhDs and the experts who are using analytics on these traditional and new sources of data, but everyday users in their day-to-day operations are making use of these tools because they have been simplified and they have been made much more real-time and meaningful for them to use for expert decision making. And in many cases, they are also getting embedded in applications through recommendation engines, so they become automated. It's not even a tool that the users have to figure out themselves, but they come as part of the application. So lots of trends going on and buzz in the industry, but the buzz is for real, and it's making tremendous difference, as we talked about, in terms of business value. So let me just say a few words about some of the difference that we have been making with our product with our customer base. One example here is a large health insurance company in Europe, where they look at many sources of data to come up with predictions around what policies make a lot of sense, that is got higher yield, what kind of prevention and treatment can be done for different types of patient groups for better outcomes and lower costs, how the physicians' billing practices affect their overall cost, and can they predict if there is fraud in the billing practices, and all of that, and evolutionary aspects of treatments for certain diseases that is hard to know ahead of time, but if they can simulate that, they can get better outcomes in the long run. But the bottom line is that there's lots of data, lots of variables that have to be brought together for the business to be meaningful. And with our platform, which, as I mentioned earlier, is MPP columnar database for analytics, they have been able to get tremendous advantage by bringing together large data sets with many variables using predictive tools, in this case, one of our partner tools called Kite, which is a European data mining tool. So one example of where we have made these differences to businesses with our customers. Another example is a media company that has been able to bring together the purchasing behavior aspects of their customers, and both from various channels, especially e-commerce channels, mobile channels, and able to predict where there might be fraud, where they could actually have better customer targeting with their campaigns, and where they can get better operational efficiencies with their overall sales. And by doing so with our platform, they have been able to get tremendous benefits and returns on investments. And it's their quotes that are most meaningful in terms of how we have transformed their business, and obviously they find our engine to be brilliant in its abilities to bring about the business value that they're looking for. Another example of how predictive analytics, when used on our platform, has brought about transformational value to our customers. So two real examples to the overall generic aspect that I talked about in the beginning. So now let's take a look at the actual techniques that we use. Our objective really is to take large data sets, and these days we use the term big data quite generously, but the issue is large data sets that also have lots of variety, like we talked about new data sources, but also has lots of velocity in terms of the speed at which the data comes in. But the data in itself is not as meaningful unless you can analyze it and get the real value that our customers are looking for. So in that regard, there's a wide variety of diversity of models that can be applied to the data sets. And predictive analytics, as Eric outlined earlier, is not new. It's been around. And so the maturity in the models have come to life these days, and when applied to big data, has tremendous benefit. But the issue is it gets complex, and the alternatives are a lot. Variables are quite a bit. Variety of data is quite a bit. Variety of models are quite a bit. So how do you make sure that you have the right combination that you can bring about value? So the idea here is not to get caught and get buried in the signal, but actually come up with buried in the data, but come up with the right value in a timely fashion. So you need to have a platform and set of techniques that you can deal with when you have this variety of diversity of models and lots of data and complex alternatives to deal with. So here is an introduction to the various techniques that we look at and we promote in terms of the various use cases in our platform. As I mentioned, our platform is right at the bottom. It's an MPP columnar analytic DBMS. So there are three methods that we primarily look at. The first is the pull-out method, method 1, in which this is the traditional way data mining and predictive analytics has been done. You pull the data out of a platform, in this case Sybase IQ, and run it on specialized predictive analytics tool. It could be IBM, the leaders in this field, typically IBM SPSS, SAS, and even the open source R community. And that's the traditional way of doing it. It's got several benefits, and we'll look at that. The second method is a push-down method, in which instead of pulling the data onto these tools, you push the algorithms from these tools onto the data so that you are able to run the execution logic right in the database and get your result sets up. And then you have the federated push-pull method, in which you do some of the processing close to the data in the database platform and some of the processing elsewhere, some in the tool, some in another server like R or Hadoop, and get the results together. And we'll explore all of these three techniques for the rest of the time that I'll talk about. So let's look at method 1. So this, as I mentioned, is a traditional method, but there are some nuances that are different. For example, the way you access the data could be through traditional drivers like ODBC, JDBC, to get the data out into these tools like R or IBM SPSS. In our case, we actually have worked very closely with SAS and built optimized drivers in which SAS is able to access our data set into their tool in a very, very efficient way and get the job done. There are lots of good benefits of these traditional methods. Of course, first of all, it's very pervasive. A lot of people are familiar with it, they're comfortable with it, and they were able to use it for a wide variety of cases. And many tools are available because it's very mature and been around for some time. And the skill set, as I mentioned, is there because of familiarity. So it works very well in many, many cases, and it's still by far the most popular method out there. In method 1, there are certain issues. When you look at these wide variety of models, when you look at this size of data, there are issues when you pull data out. I think, first of all, you have to deal with this data volume. As it grows larger, pulling data out from the database onto these tools can itself consume half the time, and that's not desirable because that's unproductive work. Then the processing time required, because you are now taking data into another tool, the time required to process it in that tool gets larger because it takes longer, because those tools are not necessarily meant to deal with the volume of data. They are meant to deal with complex algorithms. And then finally, the accuracy. Because you have so much data to move from the source to these tools, you sometimes cut corners and you take sample sets, and then you lose accuracy out of that. But the issue is balancing these three: data volume, processing time, and accuracy. And it doesn't get very easy when you have so much of choices in terms of volume and complexity. So the goal here is to push these logic away, to move away from this method 1 where necessary. It's not necessarily a good fit for every use case, but for use cases where it is needed, to push the logic into the database so that you can process it there and just have the visualization to look at your result set, and you don't have to take this data back and forth. So let's take a look at what types of techniques we have for this method to avoid this method. So first is method 2, which is you completely push down these capabilities into the database. So the idea here is one technique we have worked with is a vendor called KXCN. They're quite popular out there. And KXCN's real value is to be able to generate models automatically based on data sets gathered from Sybase IQ. And the code runs in Sybase IQ. It's a standard SQL code that you're able to then do all the processing in IQ and use the front end for analysis. And the good news about KXCN is that it doesn't require too much of sophisticated skills, because the tool itself is able to look at the various data sets, and Sybase IQ being columnar, it can store many, many columns on a flat table and provide all of those attributes as inputs to the KXCN tool that is then able to, based on just the predictor variables that users specify, come up with the right algorithms. There are obviously pros and cons to this method as well, but overall it's able to push most of the heavy lifting onto Sybase IQ. The next method is with another partner of ours. In this case, it happens to be Fuzzy Logics. The bottom line here is that you don't actually have to have a KXCN-like tool at all. You actually take the algorithms and plug them inside Sybase IQ and run standard SQL on Sybase IQ, and those algorithms get called as part of the SQL call. And there are lots of algorithms that many of you are familiar with, starting from k-means, classification to correlation, logistic regression, so on and so forth. Various types of complex algorithms can be pushed down, and it's very good for parallelization and large data set analysis, banking risk management or marketing services analysis for campaign. Wide variety of use cases that can be applied here. However, it does require the end user to be familiar with these algorithms and their applicability, and as such. But then after that, the actual implementation is plain SQL. The third method, solution in this method 2 of pushdown is if you use tools like SAS or any other popular tools, you can publish the models in the standard XML industry standard PMML format, which is basically an XML way of expressing data mining models. And then we have partnerships with vendors like Zementis that can take the PMML model and convert it into an equivalent function that can be plugged into a database server, in this case Sybase IQ, and then it again gets called by standard SQL. So in this case, you're not using specific algorithms like in the case of Fuzzy Logics or KXCN, but you're taking standard algorithms from any tool, publish them in PMML, and then have them sucked into the database engine and used in database. So different solution to a pushdown method. So here too, PMML covers a wide range of algorithms, stuff that you're quite familiar with, decision trees to neural networks, right up to association rules. The bottom line is, like I said, tools like SAS Enterprise Miner is capable of producing these algorithms and publish them in PMML format that can then be consumed in Sybase IQ. So the bottom line with method 2 is you're avoiding the data pull out of the data source into these tools. Instead, you're pushing the algorithms into the database to get the job done. Now let's look at the third method, which is a hybrid of push and pull. So in many ways, it's federation. So the queries that you fire comes to Sybase IQ, and then Sybase IQ runs part of what needs to be done, but it offloads some aspects of the model to external servers. In this case, we have an example of an R server. It offloads that through UDF calls, user-defined function calls, from Sybase IQ to this R server. So it passes on the R model execution to the R server, gets the results back, it combines it with other query processing that the analytical engine has to do, in this case Sybase IQ, and then return the results back. So what IQ has done essentially is it has pushed some of the work to the R server and then pulled back the rest of it within itself, and then it could be read by another visualization tool at top. Now, the issue here is with what kind of R models. The goal here is that you reuse what the R models that you have already built instead of reinventing the wheel and rewriting your application. But at the same time, you make use of an advantage of a very powerful analytic engine to take care of your R models transparently through standard SQL. The other methods I'm going to talk about here is not necessarily with traditional predictive analytics like R or SAS server or so on and so forth, but with a new generation of tools that's getting very popular, in this case, Hadoop. So a lot of you might be familiar with MapReduce jobs that run on Hadoop. Essentially, MapReduce jobs are nothing but a parallel programming execution of any algorithm. And these algorithms could be standard machine learning or predictive analytics algorithms to take care of large data analysis. So Hadoop tends to keep a lot of unstructured data that requires analysis, and people have written algorithms on them, MapReduce jobs on them, just like in the case of R, and you would like to reuse them. But Hadoop is not necessarily the right platform for all kinds of analysis. So at certain points, you want analysis to be done partially in IQ, partially in Hadoop. So in this case, a client-side federation where you bring partial analysis from Hadoop and partial analysis from IQ into a front-end tool. In this case, we have given an example of Quest Toad for cloud that is able to bring together predictive analysis from both platforms, let's say structured in IQ and unstructured in Hadoop, brought together at the client level. Obviously, these makes lots of sense if the processing is already done in IQ and in Hadoop, and you're just bringing together the results, because it doesn't make sense to push too much data from either of these sources to the client side. The second third solution in this data federation push-pull is that you actually don't look at Hadoop directly through the tool. The Hadoop data is brought into Sybase IQ on the fly. You fire the queries on Sybase IQ, it's able to go to Hadoop file system and fetch data on the fly into an in-memory table, combine it with Sybase IQ, and then return the results back to the user. So it's a federation of that data from Hadoop on the fly, and it never stays in Sybase IQ. It's gone once the query is finished. So this is another flavor, and a different method of that is query federation. In this case, you're not necessarily fetching data from the file system in Hadoop into Sybase IQ and combining with predictive analysis in IQ. Instead, IQ is firing a separate MapReduce job on Hadoop and getting the results of the MapReduce job instead of getting raw data from Hadoop. So a slight difference between data federation and query federation. Again, the bottom line here is federation push-pull. You actually are able to push a little bit into the Hadoop system and pull it into IQ for final results aggregation and returning it back. So another method, and finally, I would like to highlight when you have new sources of data that need more intense analysis, like social media data, textual data, that you don't necessarily want to do it in Hadoop. You can actually bring it into Sybase IQ by reading it through any web scraper software like Kapow, or from back office data files into Sybase IQ. And IQ has the ability to crack open different types of textual data formats, search through it, and reduce the corpus of text to something meaningful. Let's say you're looking for automobile sentiments. You're able to bring all of the sentiments on automobile topic. And then we have text analytical entity extraction algorithms in which we are able to pull out semantics of that data. What is a subject? What is a verb? What is an object? What are the relationships between the various terms? And able to provide textual analysis along with any transactional data that may be there. So again, you're able to federate that between Sybase IQ and external products to be able to get to that answer. So to wrap it up, we have a platform that is able to do a lot of versatile predictive analytics. You have various user communities, from data scientists to business analysts to BI programmers, who can collaborate and yet work on their problem sets with their own resources through this elastic framework, MPP columnar DBMS, and able to get the results that you need for predictive analytics. So as predictive analytics goes mainstream, we want you to know that there are many options available. You don't have to be, sort of stuck with any one option, or depending on your use case, you can use various different techniques. And we at SAP Sybase believe in openness, in variety, and giving you the choice. And the goal here was to present you with the various ways you can do predictive analytics through our platform. Thanks very much, and Eric, I would hand it back to you.
Okay, wonderful. And folks, a lot of really, really good questions already. So Joydeep, you can get your brain working on those. You'll see them in the Q&A component of the webcast console there. And in the meantime, Gregory Piatetsky is the editor of KDnuggets. We're very happy to have him on board today. So, Greg, the floor is now yours, and I'll push your slides whenever you say next slide.
Yes. Hello, Eric and Joydeep. Thank you for a nice presentation. And you can go to the next slide, please. So we've all seen the big growth of big data. In 2011, the amount of data created was over 1.8 zettabyte, and that's a word that we probably haven't seen before. That's about 1.8 billion terabytes. And most amazingly, 90% of the world data was generated in the last 2 years. Next slide, please.
Go ahead.
So why so much discussion about big data? Big data promises really the second industrial revolution. We can do all the activities better, and some initial results suggest, for example, that ad targeting can be done perhaps 30 to 70% better, and fraud detection can be done better, and so on. More importantly, big data allows creation of new activities and businesses, such as Google, Facebook, or Twitter, for example, which would not be even possible without big data. However, big data by itself is really good only for storage companies. To make business use, companies also need big analytics to realize the promise of big data. So next, please. Joydeep already covered the different dimensions of big data. I think what distinguishes what we call big data from POD, the plain old data. So volume, its databases are now measured in terabytes and petabytes and now exabytes and maybe soon zettabytes. Data velocity, data is streaming very fast. It's online, comes real time, and decisions need to be made extremely fast. And I think Joydeep also talked about the variety of data. We no longer deal with numbers. There is also text, links, images, audio, video, semantic information, XML, and so on. So next, please. It's no longer one-size-fits-all relational database that can be used for all applications. So even if traditional DBMS can scale to larger volumes, they cannot handle all the velocity and variety of data. So we see a variety of different architectures, such as columnar database, such as Sybase and in-memory, and Hadoop, which is very popular for big volume and in a very large variety of data. And there are new and hybrid platforms that appear. Perhaps topic for future webcast. And next, please. So big data has also surged in popularity. Visible Technologies recently published a slide that shows there is 1,200%, 1,211% increase in mentions of big data in social media. And I've measured a similar increase in big data usage using Google Trends. Next, please. Gartner frequently uses this hype cycle, or hype curve, to evaluate where new technology is in its adoption. Clearly, by the huge popularity of big data, number of mentions in the press, number of meetings, big data is now rising on the rising slope of hype, and our goal here is to help separate the real promise of big data from the hype to hopefully avoid the trough of disillusionment. So with that, I think we're ready to ask some questions.
Yep, go for it.
Okay, well, Joydeep, thank you again for a very nice overview. I think you've covered probably many more different approaches to analytics than I was able to think about. But first, let me ask you, what is the relationship between Sybase IQ and SAP HANA in-memory appliance?
Yes, that's a often asked question. SAP HANA has been developed as our flagship product going forward towards analyzing real-time data, because in SAP HANA everything is in memory. There is no concept of storing in disk. Everything is brought in memory, and it's columnar. At the same time, it's got row-based transactional ability. So it's one platform that is expected to change the overall landscape in how we process ERP applications, how we process BW applications, how we process overall real-time analysis of fast-flowing data. So it's primarily targeted at changing the landscape of bringing OLTP and OLAP together, doing it in real time, and doing it in memory. Now, Sybase IQ is it's primarily columnar. It doesn't have the concept of row-based, and it's targeted specifically at data warehousing and analytics. It's not meant to handle OLTP, and it is disk-based. It does have in-memory optimizations, but it is not a pure in-memory system like HANA. Now, they are used for different use cases, and there are use cases where purely SAP HANA makes a lot of sense, for example, in ERP applications or SAP BW. And there are use cases like enterprise data warehousing where Sybase IQ on its own makes perfect sense. And there are situations where both of them together can be brought together for business value. For example, in BW, you can have all of business warehouse, you have all of your current data, let's say 1 year's worth of data being analyzed in HANA, and the older data that is not touched very often gets archived into Sybase IQ, but is still available for querying as necessary. So IQ provides the right value in terms of historical data sets. And you could have the other in which you have IQ as the backbone EDW or enterprise data warehouse that is able to supply subsets of data to a SAP HANA as an agile data mart, looking at both transactional and data from enterprise data warehouse. So bottom line is the two products have different use cases. They do have similar technologies in columnar, ability to do high-performance columnar-based analysis. However, the two have different use cases and purposes. They can be used together, but they can be used on their own.
Understand. Well, thank you. So another comparison I was interested in is with one of your competitors. So TIBCO recently released TIBCO Active Spaces, which highlights the shared nothing architecture. And Sybase IQ, I've seen it described as shared everything architecture. So I was wondering if you could comment and say, in which case you think is more appropriate, and, I understand if you say that Sybase IQ is always more appropriate, but let you answer this question. So when do you think shared everything architecture is better, and other cases where shared nothing architecture like TIBCO Active Spaces is better?
Sure. First of all, TIBCO Active Spaces has a slightly different approach to data analysis. It has more of a middleware kind of approach. It's not a pure DBMS as such, like Sybase IQ. What it does is it basically takes the data from the sources and distributes it in memory in a cache-like fashion, and then each of the nodes have their own partition of the data that it analyzes. So it's shared nothing really means that none of the nodes know what the other node has in terms of the data sets, because they're disjoint and partitioned for divide and conquer. But like I said, the primary purpose of active spaces, based on what TIBCO seems to be saying, is to accelerate certain applications by caching them and analyzing them. However, if you look at the shared nothing and shared everything architecture in general, you see that shared nothing is very good at ability to look at very, very large data sets when you have a single or a few queries coming in that needs to be analyzed very quickly with this divide and conquer approach, and you want to use as much of the hardware brute force as possible to get your answer quickly. And these days, hardware being cheap, that's actually quite affordable. So shared nothing is actually a very good technique, and it provides you I/O parallelism because the data sets are not shared. There are certain drawbacks in the sense that the data has to be partitioned, and every time new data comes in, it has to be repartitioned and redistributed. But there are tools and techniques to get around that. But with shared everything, you are able to get the parallelism like shared nothing. But the biggest advantage is that since every node has the same view of the data because they're getting the data from the same place, they are able to partition the workload by having each node do a different, have heterogeneous sort of capacity. In shared nothing, every node tends to have the same capacity. It's homogeneous. In shared everything, a different node could have different capacity, and workload could be redirected to them. So it really is advantageous when you have many concurrent users coming in. Shared everything tends to do much better. But if you have really complex queries, few queries coming in, shared nothing can do very well, where I/O parallelism is heavily desired. So both have their place. Depends what your workload is and what you like to do, but typically EDWs where you have many users coming in, shared everything does pretty well.
So you would say that shared nothing is good when you have relatively few users and complex queries.
Yeah,
shared
complex
everything when you have many concurrent users.
Exactly, and you also need to have the data is well behaved in terms of partitioning, so that there is each node can be independent. Shared nothing can work pretty well. But if the partitioning gets out of whack, then shared nothing can again suffer.
Well, but thank you. Now you also have another aspect, method 2, that works with the KXCN, fuzzy logic, and Semantis. And I was wondering if you can comment on the relative popularity among your clients, among your users, of those different methods. Can you say, what percentage or number use KXCN, fuzzy logic, and Semantis?
Yeah, so let me first say that KXCN has been a partner for a while. Fuzzy logics and Semantis are new solutions we have just introduced. So they are just about going through adoption. So in terms of sheer number, obviously we have more KXCN customers because they've been around for a while. The solution's been around for a while. So in terms of percentage, I would say that 70% would be KXCN amongst these three, if I have to divide it. And then Semantis is going through a few proof of concepts and beta testing. And then fuzzy logics we have already deployed in few accounts. So the other 30% would be between these two.
Okay.
But in terms of actual advantages and disadvantages, is that something that you wanted me to articulate?
Well, KXCN uses this robust regression model that can be converted into SQL code. Probably more difficult with other algorithms like Semantis. I was wondering, right, if you can comment how much of PMML can be executed inside Sybase IQ.
Mm-hmm. So with PMML, essentially what we are doing is we are not executing the PMML natively as such. What the Semantis module does is it basically parses the PMML for correctness, syntactic sugar, and making sure that semantically it meets all of the requirements for execution. And then it converts it into UDFs, or user-defined functions, that it plugs into Sybase IQ. And then user-defined functions to Sybase IQ SQL looks like any built-in function, like max, min, average, or whatever. In this case, obviously, they're much more complex functions. So then it becomes easily executable within Sybase IQ. So there isn't a limitation of execution within Sybase IQ. It's a question of what models can be published in PMML, and I think it's limited primarily by that.
Okay, but thank you. So your slide 10 has factory analysis versus craftsman analysis, with many more models generated by model factory like KXN. So do you think modeling can be automated, putting analytics consultants out of business?
That's a good question. I think the issue there is not about putting anyone out of business. It's a question of the value it brings to the problem you're trying to solve. There are pros and cons to every approach. In this craftsman analysis, you have skilled professionals looking at the problem and coming up with the right fit, or maybe a wide variety of algorithms. Sometimes we term them as an ensemble of algorithms that is appropriate for the problem, and they use their expertise to build the training set, get it set up so that during execution time things work out. With KXN model, there are situations where you want to build many models and test them quickly in quick successions over a period of time. Let's say you're running some marketing campaign and you want to run 40 campaigns over the next 2 weeks, and you need to build many models to get to that 40. And human-based approach, craftsman analysis, may take much longer, and it may not yield the pace at which the company wants to do. And secondly, the models that they're looking at are simple or well-known models. So the factory analysis is also limited by the number of models it supports. Whereas when you have the craftsman analysis, models can be pretty much the whole universe of models that can be brought together. So it's the skill set available for a given problem, the problem you're trying to solve, the pace at which you want to generate the models, and whether the models that you want to use for the given problem is covered by your automated system. So it's not about putting any human skill out of business at all. It's totally dependent on the situation.
Well, let me ask you another question, also related to factor analysis. I think you mentioned that your client, AOK Hessent, large health insurance company, searches for patterns across all existing information, medical treatment, prescription, insurance benefits simultaneously. I think it was in one of your previous slides. Now, in such cases, when searches for patterns across all existing information, users frequently make the #1 data mining mistake of overfitting the data. And the famous example is that someone found that butter in Bangladesh was a good predictor of S&P 500 for a certain period of time. That does not mean that butter in Bangladesh will continue to be a predictor for next period. So what I was wondering, when you facilitate running so many models at the same time, do you have some tools within Sybase IQ to help your users to avoid overfitting the data when they generate so many models?
I think what we have, I think that's definitely an issue that comes up with several clients. The issue there is the techniques and the combination with the algorithms. So from an algorithm standpoint, given the problems that you're dealing with, you may want to choose the algorithm that's right fit. For example, in this AOK Hessent case, they use the neural networks approach, which is more robust and has lesser issues with overfitting or underfitting relative to many other algorithms for many variables that they are looking at. So that's the first choice of algorithm that makes a difference. Secondly, overfitting is an issue in terms of if you have too many parameters and not enough training set, that ratio is totally out of balance. So the way to get around that is to have more training set that matches up to the amount of parameters that you're using. In the AOK Hessen's case, they're looking at doctor notes, billing history, patient conditions, various types of disease groups. So the training set that they have had from historical observations, and that's where columnar system like Sybase IQ, which is able to store massive amounts of data, historically 10 years, 20 years worth of data, that they use for those model building makes a difference. Now, what we offer from our side is the set of algorithm choices, but the techniques used, in the case of factory analysis, it's automated, and it only picks as much as parameters as it supports, whereas in the craftsman analysis, in this case AOK Hessen, they picked lots of variables, I think more than 15. They had to use much more training set with neural network algorithms. So our choice is to provide them with a set of algorithms that they can use, but the rest of it is also depending on the individual doing it.
Okay.
And the technique.
Well, thank you. I mean, this is a very interesting topic for a whole other discussion. Now, also, there is a data gravity principle. The bigger the data, the harder it is to move it. So for big data, the logic must come to data. So I was wondering, for which situation use cases would your method 3, federated, be better than method 2, push down?
Yeah, I think the method 3 really is meant for situations where you have built existing techniques, and you want to augment that by going beyond those existing techniques. So, for example, you may have built your algorithms in R server, but now you also want to bring in the power of analytic DBMS like Sybase IQ to look at additional transactional data that goes beyond the R server, or the R models can actually input some of that data from Sybase IQ. So you want to bring the two together without rehauling the whole system. So that's where federated push-pull makes sense. Other is in Hadoop. You may have built some MapReduce jobs on textual data in Hadoop, and you want to bring that together with transactional data in Sybase IQ and get more value out of your analytics that's available on both sides without rehauling the system. So in those augmentation situations, the push-pull makes a lot of sense where you're using the power and the benefits of both systems. The push-down makes a lot of sense primarily where you're using one system like Sybase IQ in this case, or even purely Hadoop in certain cases, where you're able to get the whole job done within that one platform. And they tend to be less in terms of variety, and they tend to be, the data size is not necessarily an issue, but more around the variety that you tend to see. And sometimes one system is also better when you are looking for very quick ad hoc analysis where you don't have to deal with multiple systems as well. So federated push-pull is really about augmentation and making sure that your existing investments are protected. And the push-down is really for high performance where that is critical and ad hoc analysis is needed.
Okay, that's a good summary. Push-down for augmentation. Now also want to leave time for participants to ask you questions. So let me ask maybe just one more question. So I think in your last slide you had interfaces that support different types of users, and I was wondering what interfaces or software you have for supporting data discovery, data scientists.
Mm-hmm. Primarily we have partnered, as I pointed out, with vendors like XCN, SAS, SPSS, and Revolution R, and so on and so forth, to provide that. But we have just announced at SAP the tool from our Business Objects subsidiary called Business Objects Predictive Analytics. So essentially it's a data discovery tool where you're able to explore various data points that you fetch from HANA or Sybase IQ and eventually other third-party data sources. And then you're able to bring together proprietary algorithms available in the tool, as well as open source R algorithms, eventually even some of the fuzzy logic algorithms that you can model in a very graphical and user-friendly manner, and then publish the models to be run either in HANA or IQ natively, or even using PMML. So we are getting into that. We just publicly announced that I think 3 weeks ago. But we, as in the spirit of being open system, we also work with all our third-party partners.
Oh, sounds very, very interesting. Look forward to trying business object predictive analytics. So I think, Eric, we want to give participants a chance to ask some questions.
Yes, indeed. We have a lot of good questions here, folks, but you still have time to get yours in. So let me just start at the top here. We had some good questions like right off the bat. So first of all, Joydeep, thank you again. This is not Joydeep's first briefing room, folks. He is a veteran, but he did just as good the first time around. So we always appreciate the very precise and honest answers that you give. So here's the first question, Joydeep. One of the attendees asks, can multivariate analysis be used to analyze data?
Yes. In fact, there are certain algorithms in our fuzzy logic set that are used for multivariate analysis, and yes, absolutely, it can be done. And the main thing here is that the API that we provide to plug in any of these external algorithms, whether it's simulation or multivariate or classification, clustering, doesn't matter what the real issue is very versatile. It can take in data in a scalar format, vector format, table format. So it's not an issue of the type of algorithm, it's an issue of the API that we support, and our API is very versatile. So yes, multivariate is supported.
Okay, good. And here's another very, very good question. A good colleague of ours who has in fact done a briefing room and is about as sharp a guy as I've come across, Malcolm Chisholm, just published an article the other day that talks about I think he called it the coming data or conceptual model problem, and he was talking about big data and how big data is very much different from most of the traditional data that we store in relational databases. And his point is that from a data modeling perspective, it's kind of a curveball. Can you talk about modeling for big data and what that all means?
Yeah, I think it's a broad topic. Let me try to narrow the lens to something that might be more meaningful. So one of the things to take notice of when you look at analyzing any data is that you need to have some structure. Even all of these unstructured data that we talk about really is sometimes multi-structured, sometimes semi-structured, but there is some structure to it. And that's the basis for any modeling and relationships and stuff like that. So when it comes to unstructured data, typically it is read on schema. So the schema is on read. So basically when you dump that data in, for example, a Hadoop file system, there is no schema, you just store it. But when the program reads it, there is an interpretation and modeling aspect to it. In traditional relational databases, it's write on schema, schema on write. So basically you need to have some format that you write into, and then the reading becomes a trivial task because the structures and everything is well defined and the modeling can be done. So with this big data, the issue really is that the onus is on the program and the programmer to interpret that data during read and ensure all of the relationships and modeling and the MapReduce jobs understand. And that's why it tends to be a little procedural rather than declarative. But that's the way it is for now. But that is, as it gets mature, it will get. We have enough innovative minds to make it simpler and easier.
That's interesting. In other words, it really does take more work to deal with big data from that conceptual modeling perspective, right?
Yes, that's what I'm saying. The onus currently is on the programmer, but like I said, as it matures, more tools will come into the market.
Okay, good. Let me dig into another question here. So Here's a very good one. Can you mix analysis of dependent, independent, and codependent variables at the same time? And if so, how do you do that?
Well, that's a tough question for me to answer, I'll be honest. I'll have to check with some of our use cases and customers how they may have used the combination or sub-combination thereof, and get back to you. I have to own up that I can't give you a stock answer to that.
Okay, no worries. That's fine.
Eric?
Yeah, go ahead.
Can I?
Sure.
I don't think I want to answer the specific question, but I saw another question from, I think, Bill Davidson. What is meant by the term traditional predictive analytics and other big analytics? So if that's okay, maybe I'll answer this question. I think traditional predictive analytics are algorithms like decision trees or linear regression that work where you have well-defined structured data, but there are newer algorithms. For example, there are some interesting graph algorithms. Who are the people that are most influential in your social network? Or what is the sentiment of this set of messages on Twitter or Facebook? And those also require analytics, but they ask different types of questions, and traditional methods like linear regression really don't work there. So I think this is the difference between traditional predictive analytics and what some people like Michael Stonebreaker call big analytics.
Right, gotcha. Okay, of course, Dr. Stonebreaker, arguably the grandfather of modern database technology, certainly the relational models. Here's another question I'll throw out to you, Joydeep, and I know you talked about this in your presentation, but maybe just give sort of a high-level wrap-up of what are the downsides to methods 2 and 3, and how do you decide between all three methods?
Yeah, I think the downside to, let me put it as, rather than downside, as an upside to method 1, which I tried to highlight earlier, is that you have, method 1 is pervasive. I mean, people know about it, the tools are available, and pretty much works for many, many use cases. The reason you would bring method 2 and 3 is when you have data sets that are getting out of hand or complexity is getting out of hand, where method 1 becomes painful. So it's not like method 2 and 3 is needed everywhere. However, when you do use method 2 and 3, you get tremendous benefits with large data sets and complexity. The downside with method 2, let me start with that, is that you've got to make sure that you understand the various aspects of the database execution, because you're not dealing with a front-end tool like SAS anymore. Right? You're pushing everything down to the database. So you need to have some expertise around database, so that there is a learning curve there for some analysts, but not necessarily for everybody. But so that learning curve needs to be taken care, needs to be understood. Second thing is that there are two varieties of the push-down methods. One variety is you actually run the code, these external algorithms, in the kernel of the database itself, or you could be running it in the database but outside the kernel. That means each time the algorithm is run, there is a context switch in the operating system. Both of them perform well, but obviously if you run in the kernel, it's much faster. Sybase IQ, by the way, supports both. So if you're running in the kernel, you better be sure that that code is clean and it's not going to interfere with the database processing. So there is a resource contention issue that you need to take care of ahead of time. And even security if you have malicious code or untested code. So those aspects need to be well understood. You don't have these issues with the method 1. So these are certain things you need to understand ahead of time. And now you're expecting, there's an aspect of expectation. If the expectation is that, oh, every algorithm I run in push-down method is going to be faster, not necessarily so, because there are certain algorithms that are not necessarily, well set up for parallelization, for example, and distribution. Right. So in that case, you may not see as much of a benefit as some of the other algorithms that you may have seen. So you have to be careful in terms of that expectation. In terms of method 3, the downside in method 3 is that you do have a lot of glue between systems. So there is that issue with glue maintenance as the data goes back and forth between systems. You have to make sure that things are actually synced up, and you need to know in many ways what aspect of the data from the second system that you're pulling from or pushing to can handle or cannot handle. So yeah, there are you need to have a good handle on why we are doing it, and that's why I mentioned to Gregory that method 3 is primarily an augmentation approach. So you already have a system that you're augmenting. So the understanding is much clearer if you take that path instead of starting with method 3 as a federated push-pull.
Gotcha. Okay. Good answer. Excellent answer. So let me give a couple more questions here, a couple of specific questions here. Let's see. There was one really, okay. Yeah, so what about text analytics? I presume, is that going to be more in method 3, or can you talk about how you might do text analytics?
Yeah, today I'll say that, today we have it in method 3, but eventually we would like it to make it method 2, at least that's our plan. The way we do it method 3 today is that, as I mentioned, you get text feeds, let's say from a back office document server, content management server, or from the web, from any of the social media sites. So you get all of the textual data into Sybase IQ, and we have ability to make them clear text and index it like you would do in any search engine. And then once the text is indexed, we are able to reduce that corpus of text to the relevant size or relevant topics. And for that we use Boolean search, fuzzy search, whatever search algorithms are needed. Until this stage, by the way, is still text search. It's not text analytics yet. So once the corpus is reduced, then we federate by pushing it to what we have a set of algorithms in our business objects data services toolset that is able to extract semantics. It's able to do entity extraction and put more meaning to that textual data, and then give us back and returns back the result sets back to Sybase IQ and stores it in. We then store it in a structured table, a relational table. Then once that processing is done, the text analytics extraction is done into Sybase IQ in a table, then it becomes a standard analysis of that relational table. Because at that point, the data is no more text only, it is text tagged with numbers and values and weights. So that's the text analytics method. So right now it is method 3. The text comes into IQ, gets indexed, gets reduced, goes into this business objects tool, gets semantic extraction, comes back to IQ in table, then gets analyzed. Now we want to stop this round trip because if you can simplify it further, then it is better. That simplification really means that we take all of these entity extraction or text analytics algorithms and plug it into Sybase IQ's in-database API. So the data comes into IQ, gets searched in IQ and reduced in size, and then gets entity extracted also inside Sybase IQ, and then gets stored in a table for analysis. So you avoid this round trip as such. So that's my answer. Currently we have method 3, but eventually we would like to go to method 2. But method 3 works pretty good. In fact, we have just developed a demonstration around that.
Okay, great. And we have a couple other questions here. We're going a little bit over time, but I want to get to these good ones. One question simply asks, and I'll go ahead and answer this, and I'm pretty sure the speakers will both agree. One of the attendees wants to know, is big data increasing in volume because the data can actually be analyzed, or is it because storage has become relatively less expensive? And that just sounds to me like a yes and yes. Feel free to tell me otherwise if you think so. But the other question is very specific, and folks, we typically do not want a particular vendor to comment on another vendor for obvious reasons. But I figure perhaps, Greg, you might be able to talk to this a little bit. One of the attendees wanted to know how Sybase IQ compares to other columnar databases and mentioned Vertica, which is a company that Dr. Michael Stonebreaker was instrumental in starting at least. Can you comment on that?
Well, I think it's a good question. Probably I would not be able to do justice because technology keeps changing constantly. So I think I would rather skip this question. But if you have time for one question, I saw there was one question that said, doesn't big data entail big noise, and is big data anti-scientific, or big data analytics? And I guess the answer is that actually it's not anti-scientific. It just uses different types of hypotheses. It's not hypothesis-free. It just brings more different data points about individuals, customers, or different entities together.
Gotcha. Okay, folks. Well, we've answered a bunch of questions here. Very big thank you to Joydeep Das from SAP. Of course, Sybase was bought, I guess, about a year ago now, and is now really being fully.
2 years.
Is it 2 years?
Yeah, almost 2 years.
Wow, time flies when you're having fun. In fact, that was right around the time you did your first briefing room, Joydeep, as I recall.
Yeah, that's right.
So, well, congratulations. Big thank you to Greg Piatetsky, the editor of KDnuggets. We will archive this webcast for later viewing, so by all means, feel free to point your friends and colleagues to this event. We will have another event on Tuesday of next week. Of course, we do the briefing room Tuesdays at 4 o'clock Eastern. We're also going to wrap up our database research report, at least the big phase 1, on April 25th, I believe it is. You can find all that information at insideanalysis.com. And with that, I'm going to go ahead and end this event. Panelists, if you would stand by for a quick debrief. And like I say, folks, we will archive this event for later viewing, so feel free to share it with your colleagues and your friends. Thanks again, folks. You've been listening to The Briefing Room.